right, so our notes today are topic 2, geometric sequences and series. We already did the warm-up, and we said u sub 2 is another name for a sub 2, and they both mean the second term, so we got 9. This would be your sixth term, which is 19, and s sub 4 is the sum of the first 4 terms, and we got 37. Will you lock it, please? All right, so under this section, we filled in some blanks. And we said that the number that you multiply by each time is called the common ratio, which is r. A geometric sequence can also be referred to as a geometric regression. And since we know the u sub refers to the terms, this is your first term. So u sub 1 is your first term. All right, and you can find any term with this formula right here. So this is an important formula. So if I wanted to find the 100th term, that would be u sub 100. Guys, remember if you took out your phone or an AirPod or something during that break, it needs to go away. In fact, mine's still in my pocket. I need to put it away. Okay. So you would take the first term and you would multiply it by r, and the number of times you would multiply it is 1 less than that number. So here it says, consider the sequence, and in A it says, show it's geometric. So it's geometric if it has the same r value each time, okay? So to show that, you do the second divided by the first, 4 over 8. And you want to see if that's the same as the third divided by the second, the fourth divided by the third, and then what is that one, the fifth? All right, are all of these equivalent? Yeah, they all equal the fraction 1/2 or 0.5, okay? So r is equal to 1/2 or 0.5, they're all the same. So when it says to show that it's geometric, you're just showing that you have a consistent r each time. And to find r, do the term divided by the 1 in front of it. So we're going to use the formula now to find the 12th term. So I'm going to find u sub 12 or a sub 12. In IB we use u. In the American system we often use a. I'm fine with either of them now, but if the question says find u sub 12, then write u sub 12, okay? All right, so u sub 12 equals, what's the first term? 8, good. Sometimes I put my r in parentheses just because it's an easy way to show multiplication. And then we said the r is 1/2 or 0.5. And then it's raised to the n minus 1, so to the 12 minus 1. Some people just write 11. That's okay. Yeah, some of you are starting to think, I think I'd like a calculator now. So if you would, send one person from your group to get calculators for the group. Yeah. Yeah. Sorry, I'm trying to make it my calculator work. Give me a sec. Okay, so after you type it in, press enter. You get this. That's not a pretty number. So we're going to change it to a fraction. We're going to go math. Math button's here. And then fractions the first choice. All right, and that's a nice number. 1 over 256. Who wants to see it again? Good. Okay, so once you get your number here, then you press math and fraction. And then it will turn it into a fraction. So we're going to use that answer, 1 over 256. Okay. All right. So when it says find its general term on the notes, they're saying write a formula for u sub n. Okay, see this? Find its general term. That means write a formula for u sub n. And so it's going to start with this one up here. Actually, it's not, because that's not u sub 1, right? So what we're going to need to do is we're going to need to find u sub n, and we're going to need to find u sub 1, and we need to find r. So first we're going to find r. Here's 1, 2, 3, 4, 5. U sub 2 is negative 6, and u sub 5 is 162. Okay? Take a moment to think about how you might find r, knowing that it's a multiplying pattern. If you can find r, go ahead and do that. Or just talk to your neighbors about what would you do. So to get from here to here is times r, here to here is times r, and here to here is times r. So that's not times 3r though, because r times r times r is not 3r. What is it? R cubed. Good. So if we have negative 6 times r cubed, it's going to give us 162. Negative 6 times r cubed is 162. R times r times r is r cubed. Now, if you got this with trial and error, that's great. It's just good to know more than one way to do it, because maybe next time the number won't be so easy to find. How did we get r by itself first step? Get rid of that negative 6 with what? Division. With division, right. So let's divide negative 6 first. Okay, I'm going to pull up my calculator. I think it wants to work again. All right, I need to do 162 divided by negative 6. Oh, you know what I did wrong? That made a minus instead of a negative. I need to use that negative sign there. All right, negative 27. All right, so I have r cubed equals negative 27. How do you undo a cubing? Talk to your group. How do you undo a cubing? Cube root, right? Undo squaring with square root. Undo cubing with cube root. We have a cube root in the calculator. I'm just going to write that out, though, that we cube root both sides. So I'm going to do cube root of this and cube root of this, and that's going to give me r equals. Where is cube root on that calculator? Can anybody tell us where cube root is? In math. Very good. Okay. Press math. You're going to want to know where this is. Press math. Cube root is choice 4. Negative 27. Okay, so we get negative 3. All right. We also need to know u sub 1. U sub 1 is equal to, actually a u sub 2, I'm going to use u sub 2, is equal to u sub 1 times r to the 2 minus 1. And I know u sub 2 is negative 6. I don't know u sub 1. I know r is negative 3. And I'm going to divide by negative 3 now to find u sub 1. So 2 is u sub 1. So now that I know what r is and I know what u sub 1 is, I can write the formula using this equation up here. This equation up here, I'm going to substitute into it. So, final answer. U sub n stays a variable. U sub 1 is the number 2. r is the number -3, and n minus 1 stays a variable. This is the general term. Okay. K minus 1, 2k, and 21 minus k are consecutive terms of a geometric sequence. What does consecutive mean? They come one after the other, right. So those are our terms, and we need to find what k is. So that's one term, that's one term, and that's one term. One thing that we know is that the r is consistent. And how do we find the r when you know different terms? How did we find r back here? What did we divide? Divide a term by the what? The term before it, right? So we divided 4 by 8, we divided 2 by 4. That's going to give us the same r no matter what. So we're going to do that, and we're going to come up with two equations in terms of k and r. If you have two equations and two variables, you can solve that as a system. So first equation is r is equal to 2k over k minus 1. The second equation is r is equal to 21 minus k over 2k.
Wait, why do we need two different formulas for r?
So we need to have two things that are equal to r. And then we can say that they equal each other, right? Because they both equal the same r. Yeah. So now we're going to have these equations that equal each other. Now, some of you who I actually don't even see any computers out, which is great. But some people like to follow along, like on the PDF of the notes. You know, those are always available for you in there. On the PDF of the notes, they show us one way of solving this that has a little bit more work by hand. But I'm a little bit curious about whether we can just graph these, right? We have two equations. If we graphed each of them, could we just find that point of intersection and solve it that way? Maybe. So I will show you the other method too. It's longer. This method should work as long as we can get our window right on our calculator. So let's try this. One thing you need to remember is that anytime you have more than one term in a numerator or a denominator, you're going to need to put parentheses around it on your calculator. Okay? All right, so let's go to our calculators. If you don't have a calculator, go get one. And press y equals and clear out what's in there. I'm going to do x, of course, instead of k, so it's going to be 2x over k minus 1, x minus 1. Okay, and actually, you know what? I'm going to need another set of parentheses down here around that 2k. So it's going to be parentheses 21 minus x over, and I'm going to do parentheses around the 2x. I didn't need parentheses on this first 2x because order of operations will already keep them together first, but it wouldn't hurt if you're not sure on a fraction, you could put a set of parentheses on it. All right, I'm going to try zoom standard because these graphs might be messed up from a previous graph. I'm going to go zoom, and then I'm going to choose standard 6. Okay. So it looks like I see a point of intersection over here, actually, and I see another point of intersection right here. And so it looks like there's two values for k. The commands that you're going to use, I'm going to write them on the board. But I'm also gonna walk around to see who wants help finding the screen. Okay, so you're gonna do second trace, and you're gonna choose intersect. And to find one answer, it's just gonna be enter, enter, enter. 3 times. To find the second answer, before you move closer, before you press enter the 3rd time, you have to move close to it and then find it. Okay, I'll show you that in a minute, but at least go ahead and find one answer if you have the screen. If you don't have this screen, let me know so I can help you. Is that Julia? Okay. Try following those steps, okay? You got it?
I got it. X is 1.4 y. That's the second curve. I just moved it. Yeah, I just moved it this way, right?
The bigger one the bigger one
Maybe it's just like a different way of graphing it. I see you, I'm on my way. I'm coming around, guys.
This
So arithmetic is when you subtract. Yes.
I do like the answer.
That is weird. I wonder if mine is too. A similar problem? Okay. Did you do Zoom standard?
Oh, yeah.
Alright guys, yeah, let's see if this is gonna work or not for me. Okay, if it doesn't, we have another method. Are you gonna solve my problem or give me a new one? Yeah, go for it. Okay. Second, calculate, intersect, enter. Oh, second curve. Maybe it wants us to move up to it because it's like not in the right place. Second curve. Did it even move? Enter, enter. All right. Guys, the answers are here and here, but for some reason we're having trouble finding them that way. Did anybody figure this out? Like why? Sophie, go for it.
Well, you just have to move your cursor over to where the intersection is and then press.
All right, so I'm going to ask you to give me some specific directions so I can show other people, okay? So I'm going to do second, calculate, intersect. All right. Do I need to move over?
Yeah, you just move your cursor to the right. And then
To the right?
press the top part. Yeah.
Wait, I don't even see it anymore, so do I have to...
Just keep pressing it until you see it on the
Okay.
side.
Oh, there.
Yeah, and then you press enter.
All right, guys. So we just added to our directions. Sophie helped us out. You guys ready? You still do second trace intersect, but you have to use the right arrow until you see it pop over here, and then press enter, enter, enter. And your answer there is 1.4, so I'm going to write that one down. K equals 1.4, but there's another answer. I'm going to show you that one more time, okay? Second, trace, intersect. And the cursor was not here, it was over here. So we pressed the right arrow 2 times, that got us over here. You just press it until you see your cursor here. And then you press enter, enter, enter. Now this time I want this answer right here, so I'm going to try pressing right again. Yeah? Okay. Until I get closer to it. And then I'm going to press enter, 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 and there's my x equals 3 answer. Now I'm going to also share with you somebody else's work, because I think somebody else in this class has solved it a different way that's more like the notes, and that might be helpful to you too. Okay. All right, so we got k equals 1.4 and we got k equals 3. Two different answers. Okay. Let's take a look at Kenzie's work real quick. This will also be on the video, so if you want to look at it later, you can see. Kenzie multiplied and solved the equation for 0. And then what we need to do on the calculator is we need to find the zeros. I'm going to take them in a minute. I'm going to graph this equation on the calculator. I'm leaving it up there in case you want to see real quick. I'm going to freeze it while I go to my calculator. So in my y equals, I'm going to put this one. And I'm going to clear out these others. All right, so you've got negative 5x squared. And then plus 22x. And minus 21. All right, do you see the graph? It's totally different, right? Yeah. Okay, that's because we put them together into one equation. Now, what we want to know is where the answers are 0. The answers are 0 at the x-intercepts. So we're finding something different. We're finding the zeros this time. Go back to your calculator. Press second, trace, and number 2, 0. Go ahead. Okay. I'm to the left of the 0 right now. All right, I press enter once. I need to go to the right of the 0. Press enter again, and then I need to move close to the 0 and press enter again, and there's that same answer of 1.4. If you do the same thing on the other side, you can see this crossing right here at 3. You're going to get the other answer also, okay? It's another way to solve the same problem. I know I went through it really quickly, but it's on the video, so you can go back and watch that if you want to try that method instead. Okay? All right, move on to number 4. Sorry, 1,400, so 1,400, all right? And so we know that the answer is going to be greater than 1,400. All right? And then what's going to go over here is your formula. And your formula was u sub 1 times r to the n minus 1. All right, so some term is going to be greater than 1,400. Now we know u sub 1 is 6. How much is r? We can find it, right? Yeah. R is square root of 2. Good, Maddie. So r is 6 root 2 divided by 6. So it's just root 2. Mm-hmm. Okay, so we need to know when this is greater than 1,400. Now it's possible to solve this with a logarithm, but that's not always your first choice, especially like if you're doing an IB test and you've got a lot of problems to do. So again, we can solve this on your calculator. We need to know when this is going to exceed 1,400. There's a lot of different ways, but we're going to start by putting this into our y1, and we'll put this into our y2, okay? So go to your y equals again, clear it out. And I'm going to put in 6 square root of 2 raised to the x minus 1. And then in your y2, we're going to put in 1,400. Anybody have an idea what kind of zoom might work for this? It's definitely not going to show up in your standard window because your standard window only goes to 10. So you could try zoom out. Anything else? I always like to try zoom fit because sometimes zoom fit like knows where it wants to be. I'm going to try zoom fit. Yeah, zoom fit totally did not work. You see that? I've got like one down here and one over here. Zoom out, you said, huh? We'll try it. Zoom out. Oh, that did work. I did zoom fit first and then I did zoom out, but you just basically want to see where they cross, right? And then we're going to find the intersection with second, trace, intersect. And it should just work this time to do enter, enter, enter. There we go. So I'm seeing about 16.7. Okay, so we get n equals 16.7. But we need to figure out what that means because that's not our final answer. Okay? For n, you can have a 16th term, and you can have a 17th term, and you can have an 18th term, but you can't have a 16.7 term. So it needs to exceed 1400. So after the 16th term, has it exceeded 1400? It didn't. Because remember it took all the way to 16.7 before it exceeded 1400. So the 16th term did not exceed 1400. It was not until the what term? The 17th term. Even if it was 16.1, you would have to say the 17th term because the 16th term wouldn't have been big enough. It's not the same as rounding. With rounding, a 16.1 would go down to 16. But in this case, the 16th term was not big enough. So we're going to go back and we're going to write, it's the 17th term.
That's the only.
Some people are having the question, like the zooming is just not working for them, okay? And that happens sometimes. Sometimes zoom fit, zoom out, like none of them work. And so you can set your window manually. Let me show you over here. Press window, okay? And think for a moment. You know that one of your lines is y equals 1400. So your y, you want to see a little bit more than that. So I would set your y max at, down here, I can set my y max to be like 1500. All right. Now, your x is the number of the term. You're not going to have a negative term, so you don't have to worry about any negative x values. But you want to make sure you see plenty of terms. So you could try an x max. I have 40 here, and that's fine. You could try 50. And then if your graph does not show you what you want to see, then you can adjust it. All right? But you can adjust your window manually anytime the zoom is not working for you. All right, we need to get through these notes, guys. We have an exit ticket. We have like 2 exit tickets, so we have work to do. All right, refocus here. Sum. No, we're not on sum. We're on growth and decay. Sorry. Good. All right. All right, so in situations where there's growth and decay, you have this equation right here. It's very similar to the other equation. They use u sub 0 for your starting amount, and they use r to the n instead of r to the n minus 1. So it's related. It's an exponential growth or decay, which is related to geometric series and sequences. Related to geometric, but it's a little bit different in its formula. Okay? We're going to do a problem like this, and you have some delta mass assigned. Some of you have already started them. I don't know if I assigned the geometric one yet, but I will. And we're going to use this equation here for these. The initial population of the rabbits was 50, so that's my u sub 0. And the population increases by 7% each week. So 7% is not my r, but it's related to my r. If I'm increasing by 7%, I'm starting at 100% and I'm adding 7%. So what percent am I at? I'm at 107%. Now, how do you write 107% as a decimal? It's 1.07, yeah. So this is telling you 107% because of the increase. And then your R value is 1.07. So to answer I, I'm going to find u sub 15 equals the initial amount, which was 50, times my R, 1.07 to the 15. And you do exactly the same thing for 30. U sub 30, 50, 1.07 to the 30. All right, so if you haven't yet typed those in your calculator, go ahead and do that. What am I doing? I don't want to. All right. So I'm getting this. If we're talking about rabbits, what should we round to? Whole number, yeah. So how many rabbits for the first one? 138 rabbits. And for the second one? 381 rabbits. Yeah. All right, how long will it take for the population to reach 500? So we need to know when the answer to this is 500. And we're going to graph it on our calculator again. So now we know how to set our window, so that should be helpful. Let's see what we're going to graph. Close this. So we have this equation. 500 is equal to 50 times 1.07 to the x. And we're going to put one side of the equation in your y1 and the other one in your y2. All right, so my y's look like that. And when I graph it, I don't know if the window I have already, oh, look at that. The last window I made still works for me. If it doesn't, you can press window and you can make your numbers bigger so you can see more points. Okay, so second, trace, intersect. Enter, enter, enter. Okay, so I'm getting 34.03. Okay, so this time it says how long. It doesn't say something specific like how many terms or how many years or how many weeks. So we can answer more generally here. This would be just after 34 weeks.
Ms. Nora,
Mhm.
why for the first part of the question, why would you round up on the rabbits?
Round up on the what?
Like the rabbits.
Oh, here?
Yeah.
So you want to say that we didn't quite make that rabbit yet?
Yeah.
That's a good question. It's not gonna be like, it's not gonna be 380 rabbits or 380, it's not gonna be 380 point something rabbits, right, for sure?
Yeah.
It's gonna be one of these, and it's like a curve of best fit, so it's not an exact answer either way. So for this one, I think you're like making your best guess. It's closer to 381 rabbits than it is to 380 rabbits.
Okay. So
I get that that's still a little bit confusing, and I'll think about a better way to explain the difference between that and the other one. Okay.
thank you.
All right, guys, let's turn the page. All right, we have two different kinds of series. A series is when you do what to a sequence? We already did arithmetic series, guys. A series is when you do what? Add it, yeah. A series is when you add up your sequence, okay? So here's a sequence, and we add it up with the pluses, and we have all of a sudden a series. You can have a finite geometric series, and you can have an infinite geometric series. And the interesting thing is that there are some infinite geometric series where you're adding an infinite number of terms, but you get a single answer. It doesn't just go to infinity. We'll see about that in a minute. That was just kind of a spoiler. We're going to do this part first. All right. All right, so for the sum, it looks like it's two different equations. They're really the same equation. You only need to use one of these. I don't know why it's written twice. I mean, it's true that they're both equal to the sum, but if you look, this is the opposite of this, and this is the opposite of this. So it's just like that idea, negative divided by negative is a positive. It's not a big deal. So yes, like, you can use either of them. All right. Find the sum to 12 terms. So we need to know R, and we need to know U sub 1. I'm going to find R by dividing the second term by the what? First term, very good. All right, so I'm going to do 6 divided by 2. And my R is 3. My U sub 1 is?
2.
It's 2, very good. Okay. So I'm going to use this one, but if you want to use this one, you're all good for that. So I'm doing S sub 12. U sub 1 is 2. R, 3, to the N. What's N? 12, good. N equals 12. 12 terms. Minus 1. And then R minus 1. All right, if you do this on your calculator, remember that you're going to need some extra parentheses. You need parentheses to hold your numerator together. You need parentheses to hold your denominator together. Okay? Good job comparing answers. All right, I entered it like this. Instead of typing 3 minus 1, I just put in 2. But I should get the same as you. Did you guys get 531,440? Very good. It's weird because the answer key says something different, which, like normally we would round to 3 sig figs, but that's like a lot of rounding for this one. I'm just gonna write the exact answer for now. So I'm getting 531,440. All right. In number 7, it says find a formula. So we're going to write a formula in terms of S sub n and n. We need to know U sub 1 and R. So what would U sub 1 be? For this one. What's your first term? 9. So U sub 1 is 9. To find R, I can do the second term divided by the first. That simplifies to negative 1/3. In your notes, we're going to write this formula out, and in your notes, they do a lot of simplifying, and you can do that. It would be good to like look over the notes to see how to do it, but we're not going to simplify it for the sake of time right now. A lot of times IB doesn't require you to simplify a formula. So we're gonna plug these into your formula. So your formula is S sub n equals your first term, 9. And then my R is negative 1/3. That's being raised to the n minus 1. And then here I have R, which is negative 1/3 minus 1. I just substituted into the formula here. I can simplify my denominator. So negative 1/3 minus 1, what's that? As a fraction. You can subtract it and then press math frac. What do you get? Or you can do it in your head. Anybody else get negative 4/3? Okay. So this denominator makes negative 4/3. Like that. So you could leave it like that, or you could divide 9 by negative 4/3 to make a nicer coefficient there. It would give you a coefficient of negative 27/4 if you do 9 divided by negative 4/3, and then you would have negative 1/3 to the n, and then minus 1. So I did simplify a little bit, but you really don't have to simplify that much. All right, almost done with the talking. I think we got 2 more problems to write about. Oh, I like this infinite question, actually. It's a good one. But we're still not there yet. We're still on geometric. Okay, so we have to find n. They tell us the sum is 635. So 635 equals, for U sub 1, we're going to put in the first term, 5. For R, where's our R? Oh, 2, got it. We don't know n. And then down here, 2 minus 1. All right, so 2 minus 1 is 1, and anything divided by 1 is itself. So we don't really need this part here. So this whole thing simplifies to 635 equals 5 to the 2 to the n minus 1. How are we going to solve that? How have we solved all of these problems where our variables in the exponent? Divide by 5. Okay, so you could divide by 5 to make it a simpler problem. I would not argue with that at all. But you don't have to also. You can just put this one in your y1 and put this one in your y2. But if you do divide by 5, you'll get a slightly simpler problem. Maybe it'll be easier to fit in your window. So definitely can argue that. Okay? All right, and so when you do that, I'm not going to do that right now because we've done like 5 problems like this. When you do that, you should get, let's see. So you should get the 0.7128, which means that your n is 7. So if you do y1 and y2 and you do second calc intersect, you should get that. You can try that at home too. Okay. Last problem is about an infinite geometric series. If the absolute value of r is less than 1, then the infinite geometric series will converge to the limiting sum. And this is the formula, okay? This is my formula right here for an infinite series. However, you can only have an infinite series if the absolute value of r is less than 1. So I'll give you an r value and you tell me if it will converge, all right? R equals 3, will it converge? No. R equals negative 0.6, will it converge? Yes, good. Because the absolute value of negative 0.6 is 0.6, and that's less than 1. All right, R equals 1.7, will it converge? No. R equals 0.2, will it converge? Yeah. Okay. So sometimes if your R is has an absolute value less than 1, then the infinite series will converge, meaning that you can get a number answer that's not infinity. All right? All right, so the question is to write 0.7 repeating as a rational number. So you know 0.7 repeating is like 0.7777 ... right? And so you can think of it as this geometric series, 0.7 plus 0.07 plus 0.007, etc., right? If I write it as a geometric series like this, what's my R value? What's the R value that gets you from one term to the next? Okay, so divide by 10 is the same as multiply by what fraction? 1/10. Good. So divide by 10, same as multiply by 1/10, which is 0.1, right? So one way to find R is to do the second term divided by the first term. And you're going to get 0.1, which is 1/10. That's your R value. Once you know your R value and you know your first value, we know u sub 1 is 0.7, we can use this formula right here. All right, so the first term is 0.7. 1 minus 0.1. All right, divide that and let's find out what the sum is. Do math fraction. What do you get with math fraction? What fraction? 7/9, right? It makes sense because it's 0.7 over 0.9. So 7/9. So the fraction 7/9 is equal to 0.7777777, repeating like that. And this is a really interesting application of a geometric series. All right. That was a lot of